Okay, so next let's look at weighted graphs. Okay, so what is a weighted graph? So a weighted graph is basically a graph in which instead of just having random edges that don't have any, basically the uncharacterized edges, we have edges that have a number or something we call a weight. So if you see a number above an edge, we call it a weight. So it's not necessarily like the weight of the line, but it can have a variety of different meanings. And you'll learn a few applications in year 12. In year 11, all they really want you to do is just have a broad or a general understanding of what a weighted graph is compared to an unweighted graph. So it can resemble a variety of different things. So it might resemble the distance between two particular points. It might resemble the number of people that can go between two particular points. So thinking about, for example, an airport maybe, from point F to point G, 7 people can pass per minute or something like that. It can resemble a variety of different things, but that will be specified to you in the question. So then we have a problem that we need to solve. And the problem is called a shortest path problem. So that problem is basically a type of problem in which you have to determine the shortest path that exists between two particular points on a weighted graph. Okay, so for example, let's just say I'm sitting at B and I want to go to G. Now there might be multiple paths that I can travel on, and your task will usually be to determine the shortest one. Okay? In year 12 next year, in Unit 4, you will be learning about a specific algorithm that can enable you to do that. However, in year 11, you want to just use a visual method because the graphs that you're going to get are not going to be that complicated. Okay? Oops. So let's have a look at this example. So like I said, let's just say we want to go from B to G. So what are the different paths that I can take? So I can go from B to A to F to G. I can go from B to C to F to G. Or I can go directly from B to G. So let's determine what each of these paths are and how much. So let's just see, let's just take the weight as the distance in kilometers. So if we went from A to B to A to F to G, that would be what? So it would be 3 plus 9 plus 1. Okay? Which comes out to 13. Another path that we can potentially take is B to F to G. Now be reasonable, like obviously we can take B to E to, C to F to G, but that's like way too long. So be reasonable as well. Don't waste your time. So B, C, F, G. That would be 6 plus 3 plus 1, which is 9 plus 1, 9 plus 1, 10. Okay, it's already shorter than the first part that we looked at. Now, or we can go directly from B to G. B to G. And that is just one path, 15. So therefore, the shortest path will be this one, B, C, F, G. So that's what we basically do when we're determining the shortest path. And like I said, next year we will be learning about the Dijkstra's algorithm, which is an algorithm that allows you to determine it for sure. This year, the graphs will be pretty simple. You should be able to just look at them and determine it, or use something like this.